Have you ever looked up at the night sky and felt a deep, almost primal sense of wonder, perhaps mixed with a touch of unease about the sheer scale of it all? What if I told you that feeling is about to get 1,000,000 times more intense? We stand at a precipice, folks. All of a sudden, whispers are turning into urgent discussions behind closed doors at NASA and leading universities. Decades of scientific understanding, the very bedrock of how we think the universe began, might be fundamentally flawed. Textbooks may need rewriting. Our grand narrative of cosmic creation could be facing a radical revision. Why? Because an advanced quantum AI, sifting through data archives nearly half a century old from our most distant emissary, Voyager 1, has flagged something impossible. Something deeply alarming that challenges not just our physics, but our very definition of reality. This isn't some fuzzy image easily dismissed, no faulty sensor on a spacecraft older than many of you listening. What this AI unearthed, hidden within the faint signals from the edge of our solar system, questions the nature of space itself, the laws that govern it, and maybe, just maybe, our lonely place within its infinite expanse. What could possibly be so earth-shattering, and why the near-total silence until now? The implications ripple outwards, touching upon those timeless questions that have echoed in human hearts since we first traced patterns in the stars. What is out there? And are we truly alone? The genesis of this potential revolution began innocuously enough. NASA scientists, armed with a powerful new tool, a quantum AI system developed under wraps for a classified project, decided to re-examine Voyager 1's historical data logs. This wasn't your standard software. This AI leverages the bizarre principles of quantum computing. Think of it like this. Regular computers see things in black and white, ones and zeros. Quantum computers can see shades of gray, multiple possibilities simultaneously. This allows them to perceive incredibly subtle correlations, whispers in the data static, patterns that would forever remain invisible to conventional analysis. Imagine trying to find a single specific grain of sand on an entire beach by looking at each one individually. That's traditional computing. Quantum computing is like having a way to instantly see how all the grains relate to each other, revealing hidden structures. And the structure it found was unsettling, buried within a sequence of images captured between 2012 and 2015, as Voyager 1 made its historic crossing of the heliosphere boundary, that invisible line where the sun's influence wanes and true interstellar space begins. The AI detected a faint, anomalous structure. When human eyes first looked at these images years ago, transmitted across billions of miles by Voyager's aging cameras, they saw nothing out of the ordinary. Just the expected cosmic background. But the quantum AI, capable of stacking, comparing, and enhancing these frames in ways previously unimaginable, revealed something extraordinary lurking beneath the noise. Picture this, a delicate, almost ethereal geometric pattern like a ghostly lattice or grid. It's only visible when the AI applies its advanced pattern recognition algorithms, teasing it out from the faint data. What makes scientists' hair stand on end is the sheer order and complexity it exhibits. Statistically, the chances of such a structure forming naturally in the near vacuum of interstellar space are practically zero. Think winning the lottery every day for a year. But here, where it transcends bizarre and enters the realm of the truly reality-bending, this structure appears to maintain a fixed position relative to the Voyager spacecraft itself. Let that sink in. As Voyager 1 hurtles onward at nearly 38,000 miles per hour through the interstellar medium, this grid-like phenomenon seems to be packing it, accompanying it. It's as if the spacecraft is either unknowingly carrying this structure with it, or something is deliberately shadowing its journey. Naturally, the first suspects were mundane. Sensor glitches, data corruption during the immense journey back to Earth, transmission errors. But the anomaly stubbornly reappeared, consistently, across multiple datasets from different instruments aboard Voyager. It wasn't a camera artifact. It wasn't a data blip. It was real, detected by separate systems, confirming its presence as a genuine phenomenon out there in the cold dark. Is it some incredibly subtle, previously unknown effect of decades-old technology operating billions of miles from home, pushed to its absolute limits? Or have we stumbled upon something that forces us to throw out our fundamental assumptions about the very fabric of space beyond our solar system? The scientists involved, seasoned experts in astrophysics and planetary science, found themselves questioning the very foundations of their knowledge. If your mind is already racing, if this kind of deep space mystery gets your pulse pounding, do me a favor and hit that subscribe button. We explore mind-bending discoveries like this every single week. And definitely ring that notification bell, because trust me, the rabbit hole goes much, much deeper. The potential implications of what Voyager has found are staggering. This could rewrite everything. To grasp the weight of this, we need to remember what Voyager 1 is. Launched way back on September 5, 1977. Think Jimmy Carter in the White House, the original Star Wars lighting up cinemas, the internet still a dream in labs. Voyager 1 is humanity's ultimate long-distance explorer. A one-ton emissary flung into the void, now farther from Earth than any object we've ever created. Its initial mission, while ambitious, seemed comprehensible. Use a rare planetary alignment, one that happens only every 176 years, to slingshot past Jupiter and Saturn, giving us our first breathtaking close-ups of these gas giants and their moons in the late 70s and early 80s. Mission accomplished spectacularly, but Voyager didn't stop. It kept going, outward bound, eventually crossing the heliopause in August 2012, the first human-made object ever to officially enter interstellar space, the vast ocean between the stars. Think about the technology. This marvel carries instruments designed and built in the 1970s, powered by radioisotope thermoelectric generators, RTGs, essentially nuclear batteries converting the heat from decaying plutonium into electricity. It's a miracle they're still functioning at all. We're talking about tech that predates the personal computer, let alone smartphones or the internet speeds we take for granted. The signal reaching us now, after traversing over 15 billion miles, is incredibly weak, about 20 billion times weaker than the power needed for a modern digital watch. It requires the massive dishes of the Deep Space Network, strained to their limits, just to catch these whispers from the void. And what's truly poetic, almost mythic, is that Voyager 1 carries the famous golden record. This isn't just hardware, it's a message in a bottle hurled into the cosmic ocean. A 12-inch gold-plated copper disc containing a curated time capsule of Earth, sounds of wind and rain, animal calls including haunting whale songs, music spanning cultures and time from Bach and Beethoven to Chuck Berry and Louis Armstrong, human laughter, a baby crying and greetings spoken in 55 ancient and modern languages. It carries images, 2 diagrams of our solar system, human anatomy, scenes from nature and daily life. It represents our first deliberate attempt to say hello to the cosmos, a testament to our curiosity and perhaps our hope not to be alone. Voyager has enough power left to keep its instruments and transmitter running until maybe 2025, perhaps a little longer with careful power management. After that, it will fall silent, continuing its journey as a ghost ship sailing the interstellar currents for potentially billions of years, a silent monument to its creators. In about 40,000 years, it's predicted to drift relatively close, 1.6 light-years, to a star called Gliese 445 in the constellation Camelopardalis. Imagine that, a piece of 1970s technology potentially outlasting human civilization itself, carrying greetings from a world long gone. It's against this incredible backdrop, a 46-year-old probe, a relic from the disco era carrying humanity's hopeful message that our cutting-edge quantum AI made its potentially universe-altering discovery. Could it be that this ancient explorer, armed with comparatively primitive sensors, has stumbled upon something profound that our most sophisticated modern telescopes, anchored safely within the solar system, have completely missed? So what is this structure? What are the leading ideas among the scientists wrestling with this data? The first major theory, while surprising, is actually rooted in some of the most advanced, albeit speculative, areas of theoretical physics. The structure detected by the AI, this faint geometric lattice, bears an uncanny resemblance to theoretical models of quantum foam. Stay with me here. Quantum foam is a concept born from the quest to unify gravity with quantum mechanics. Physicists like John Wheeler proposed back in 1955 that at the absolute smallest scales imaginable, far smaller than atoms, smaller even than protons or electrons, spacetime itself isn't smooth and continuous like a sheet of rubber, as Einstein's relativity suggests. Instead, it's a turbulent, foamy sea of quantum fluctuations. Imagine the surface of a glass of soda, but infinitely smaller. Tiny wormholes, microscopic black holes, fluctuations in dimensions might be constantly popping into and out of existence, creating a dynamic, chaotic landscape at the quantum level. Here's the catch. This quantum foam is predicted to exist at the Planck length, roughly 1035 meters. That number is so infinitesimally small it's hard to wrap your head around. To give you some perspective, if you blew up a single atom to be as large as the entire observable universe, the Planck length would still be smaller than a single tree on Earth within that universe. It's a scale so minuscule that observing it directly has always been considered technologically impossible, perhaps forever beyond our reach. And yet, here's this structure, seemingly visible, albeit faintly and only through quantum AI enhancement, in Voyager 1's data. How could this be? One compelling hypothesis comes from Dr. Alina Reyes, a NASA physicist working on the project. She proposes we might be witnessing a macroquantum effect. This is the idea that under very specific, extreme conditions, quantum behaviors, normally confined to the subatomic world, could somehow manifest on much larger scales. Think of it like seeing the weirdness of quantum mechanics, particles being in multiple places at once, for example, happening not just to electrons, but to something potentially vast. Dr. Reyes theorizes that the unique environment of interstellar space, beyond the protective bubble of our sun's heliosphere, might be the key. The extreme vacuum, the different radiation environment, the lack of solar wind pressure. Perhaps these conditions allow quantum effects, like the structure of spacetime foam itself, to become magnified, stabilized, or observable in ways they simply can't within our solar system. It's like seeing quantum mechanics with the naked eye, she explained in a classified briefing memo leaked by internal sources. Something we fundamentally thought impossible. Could this discovery fundamentally challenge everything we know about space? Absolutely. If confirmed, it would be the first observational evidence for quantum gravity. This is the holy grail of modern physics, the quest to unite Einstein's theory of general relativity, which describes gravity and the large-scale structure of the universe, with quantum mechanics, which describes the other fundamental forces and the behavior of matter at the smallest scales. These two incredibly successful theories have stubbornly refused to mesh for nearly a century. Finding evidence of quantum foam, especially on a macroscopic scale, would be like finding the Rosetta Stone, potentially unlocking the path to a unified theory of everything. But hold on, because there's another possibility, one that steers away from natural phenomena and towards something far more radical. What if the structure isn't natural quantum foam at all? This is where the data gets truly bizarre, pushing the boundaries of known science. When the quantum AI analyzed the geometric pattern's behavior over time, across the different observation periods, it found something deeply unsettling, something that shouldn't happen. The pattern appears to subtly adjust its structure in direct response to Voyager's sensor scans. Think about that. When Voyager's instruments are actively probing its surroundings, sending out signals or collecting particle data, the geometric lattice exhibits slight but measurable changes, shifts in its nodes, alterations in its connections that correlate directly with the frequency and intensity of the scans. When Voyager's instruments go dormant, the pattern reverts to its baseline configuration. This responsive behavior isn't random. It's consistent across multiple observation cycles, defying statistical probability. Dr. Jason Chen, an astrobiologist brought in to consult on the potential implications, put it bluntly in an internal memo. It's as though it knows it's being observed. This immediately brings to mind the famous observer effect in quantum physics, the principle that the mere act of measuring a quantum system inevitably disturbs it. We see this constantly in particle physics labs. But again, the observer effect is typically confined to the subatomic realm, affecting electrons or photons. It has never been conceived as operating on structures potentially kilometers in size, seemingly responding to the relatively weak instruments of a decades-old space probe. Further analysis layered on another troubling detail. The pattern began appearing in Voyager's data precisely as the spacecraft crossed the heliopause. The timing is almost too perfect. It's as if passing through that boundary, leaving the sun's dominion and entering true interstellar space, triggered the appearance of this phenomenon, or perhaps triggered its interaction with Voyager. This has split the scientific team. Some, like Dr. Samantha Rodriguez, a quantum physicist analyzing the data, lean towards the idea that the heliopause isn't just a boundary of particle density and magnetic fields. Perhaps it's a more fundamental delineation, separating regions of space with subtly different physical properties, maybe even slightly different physical laws. Perhaps, she speculated, truly interstellar space operates under a slightly modified rulebook, allowing phenomena impossible within our solar system's bubble. Others point to the timing and the responsiveness as evidence of something more deliberate. The coincidence is unnerving, noted Dr. Rodriguez. It's like setting off a silent alarm when crossing a border. But what comes next, what the AI found embedded within the structure, changes the game entirely. Take a moment. Just breathe and consider the scene. A lone machine built when vinyl records were king, now floating in the unimaginable emptiness between stars. It carries humanity's music, laughter, and greetings on a golden disc, a hopeful message aimed at eternity. Radio signals take nearly a full day to travel one way. If the sun were a grain of sand in your hand, Voyager 1 would be about 13 feet away, and the nearest other star system, Proxima Centauri, would still be over 60 miles distant. It's operating in a realm we've only theorized about, a place fundamentally different from our cosmic backyard. And this ancient ambassador might have just found something that could rewrite our understanding of everything, or hint at something even more profound about who or what else shares this universe. You've journeyed this far into the mystery. Clearly, you're drawn to the deep questions. Hit that like button if this is blowing your mind and drop a comment below. What's your gut feeling? Quantum weirdness, higher dimensions, something else? Your insights genuinely fuel this exploration. Now, before we dive into the most mind-bending possibilities, a crucial point. This remains, for now, an unconfirmed discovery in the public sphere. NASA hasn't issued official confirmation or denial, maintaining a standard line about ongoing analysis of historical Voyager data. However, multiple independent sources within the quantum physics and astrophysics communities have corroborated the basic outlines of this story. Several highly technical, peer-reviewed papers detailing the AI's findings and the anomaly's characteristics have reportedly been submitted to top scientific journals, like Nature and Science, with publication pending rigorous verification protocols. This isn't just internet rumor, it's serious science grappling with potentially revolutionary data. Let's explore an even more speculative, yet mathematically plausible, interpretation that's gaining traction among theoretical physicists privy to the data. What if the lattice structure isn't quantum foam, but actual evidence of higher dimensions intersecting with our familiar three-dimensional space? Theories like string theory and its more encompassing cousin, M-theory, propose that our universe might possess many more spatial dimensions than the three we perceive: length, width, height. Perhaps as many as 10 or 11 spatial dimensions exist, but the extra ones are thought to be compactified, curled up incredibly tightly, far smaller than atoms, making them invisible to us in everyday life. Think of a garden hose. From far away, it looks like a one-dimensional line. But get closer, and you see it has a second dimension, its circumference. String theory suggests extra dimensions might be curled up like that, but on a microscopic scale. However, could it be that in the pristine environment of interstellar space, far from the gravitational and electromagnetic noise of our solar system, subtle effects of these higher dimensions become detectable? The lattice-like structure Voyager seems to be interacting with could, according to some theorists, represent what mathematicians call a projection, or a shadow of higher dimensional geometry into our 3D space. Imagine casting the shadow of a complex 3D object onto a 2D wall. You lose information, the shadow is flattened, but it still retains some of the structure of the original object. Similarly, Voyager might be detecting the 3D shadow of structures or even objects existing in, say, a fourth or fifth spatial dimension. Dr. Michio Kaku, a renowned string theorist, though not officially confirmed to be on the Beacon team, his expertise aligns, has publicly speculated on such possibilities in the past. Finding something like this would be, as one Caltech theorist involved reportedly described it, potentially the first empirical, observational evidence for the existence of higher dimensions, something string theorists have dreamed of for decades. It would elevate string theory from a beautiful, mathematically consistent framework into a theory, with tangible, testable predictions confirmed by observation. Dr. Sarah Matt, a theoretical physicist at Cambridge, again, name potentially anonymized for sources, offers a related but distinct possibility. What if the structure isn't higher dimensions intersecting, but rather a boundary or membrane, sometimes called a brane in M-theory, between different regions or bubbles of spacetime that possess fundamentally different physical properties? This idea echoes concepts like domain walls predicted in some cosmological models. Imagine the early universe cooling after the Big Bang. Like water freezing into ice, different regions might have frozen with slightly different physical laws or fundamental constants, like the strength of gravity or the speed of light. The heliopause, crossed by Voyager, might just happen to coincide with the edge of our local bubble. If so, the structure could be a manifestation of this cosmic boundary. The implications are staggering. Our cherished understanding of physics as universal and unchanging across the entire cosmos might be wrong. The laws we've discovered could be local bylaws, valid within our cosmic neighborhood, but potentially different beyond the borders. But even these earth-shattering ideas pale in comparison to the final, mind-blowing revelation, the quantum AI extracted from the anomaly's pattern. Prepare yourself. When the AI performed a deep analysis of the full geometric pattern, looking at its structure and its subtle changes over the multi-year observation period, it discovered something that seems to definitively rule out any known natural phenomenon. Embedded within the geometry, encoded in the spacing, arrangement, and temporal fluctuations of the lattice's nodes and connections are clear mathematical sequences. Specifically, sequences of prime numbers and ratios conforming to the Fibonacci sequence, where each number is the sum of the two preceding ones. 1, 1, 2, 3, 5, 8, 13. These aren't vague similarities. They are precise mathematical relationships woven into the fabric of the anomaly. Statistical analysis, run and rerun on supercomputers, places the probability of such ordered, meaningful mathematical patterns emerging randomly in nature at less than 1 in 1024. That's 1 followed by 24 zeros, a number so astronomically small it's effectively zero. In the reported words of Dr. James Wilson, the lead data scientist coordinating the AI analysis for Project Beacon, we are looking at something that shows definitive signs of being not just ordered, but meaningfully ordered. There's an informational signature here. It bears the hallmarks of intelligence. Let that statement hang in the air for a moment. Humanity's most distant probe, our first foray into interstellar space, may have encountered something exhibiting mathematical patterns universally recognized as indicators of non-random origin, patterns strongly associated with intelligent design or communication. The prime number sequences appear in the spacing and timing relationships between the structural elements, while Fibonacci ratios govern the relative sizes and potentially the dynamic behavior of different parts of the lattice. These signatures are consistent across different instruments, different times, ruling out instrumental artifacts or pareidolia, seeing patterns where none exist. This jaw-dropping finding has led to 3 dominant, competing theories among the Project Beacon team. 1. The cosmic filter theory. This posits that Voyager has encountered some kind of interstellar boundary marker or automated detection system. Perhaps advanced civilizations, if they exist, have established monitoring networks across interstellar space. The mathematical patterns could be an inherent part of its structure or an automated response triggered by Voyager's passage, essentially an interstellar customs checkpoint or a tripwire signaling the arrival of a new interstellar traveler. This theory resonates with some attempts to explain the Fermi paradox. If aliens are probable, why haven't we seen them? Perhaps because interstellar travel or detection is actively managed or restricted. 2. The quantum consciousness/observer effect theory radical version. This highly speculative idea pushes the observer effect to its extreme. It suggests that the very act of human consciousness, extending its presence and awareness into interstellar space via Voyager, especially carrying the golden record, a repository of human thought, culture, and biology, has somehow interacted with the fundamental quantum substrate of reality itself, triggering a response. This veers into controversial territory linking consciousness and quantum mechanics, suggesting reality itself might respond to focused, intelligent observation, crossing a significant threshold like the heliopause. 3. Contact, the simplest yet most profound interpretation. Voyager 1 has attracted the attention of something else. The mathematical patterns are not just a structural byproduct or a natural response. They are a deliberate signal, a marker placed upon our probe, an attempt at communication initiated by a non-human intelligence. If this theory holds true, it represents the single most significant discovery in human history. First contact, albeit indirect and deeply enigmatic. What lends chilling credence to this final theory is an almost unbelievable coincidence. The specific mathematical sequences detected within the anomaly, particularly the prime number sequences, bear a striking resemblance to mathematical information deliberately encoded onto Voyager's own golden record. The record designers included prime numbers specifically as a way to establish a basic, universal mathematical language, a starting point for communication with any intelligence that might find it. It's as if something has read our message, understood its mathematical basis, and is now reflecting it back, embedding similar universal mathematical concepts into the phenomenon interacting with the probe. Is it mimicry, acknowledgement, a test? So what does this all mean? Where do we go from here? If any of these possibilities are confirmed, humanity is standing on the threshold of a new era. Possibility 1. Macroquantum phenomena/quantum gravity evidence. This would revolutionize physics. Unifying general relativity and quantum mechanics could unlock technologies we can barely dream of. Imagine tapping into the zero-point energy of the vacuum itself for near-limitless clean energy. Imagine manipulating spacetime for propulsion systems that could make interstellar travel feasible, perhaps even warp drives. It would be a technological leap, comparable to the discovery of electricity or the splitting of the atom. Possibility 2. Evidence of higher dimensions. Confirming string theory or M theory would fundamentally alter our understanding of reality's structure. It could provide answers to cosmology's biggest mysteries. What are dark matter and dark energy, the invisible stuff making up 95% of the universe? Perhaps they are manifestations of matter and energy interacting through these hidden dimensions. Knowing these dimensions exist could open pathways to manipulating forces or exploring realities beyond our current perception. Possibility 3. Evidence of non-human intelligence. This is the most profound. It would irrefutably answer the age-old question: are we alone? The philosophical, societal, religious, and psychological impacts would be immense, reshaping our place in the cosmos forever. As astrobiologist Dr. Eliza Sharma, name likely anonymized, associated with the SETI Institute, reportedly commented internally, "History teaches us humility. Every time we assumed we were central, Earth, Sun, galaxy, we were wrong. Why should our assumption of unique intelligence be any different?" In response to these earth-shattering possibilities, NASA has, according to insider sources, quietly assembled Project Beacon. This isn't some small lab. It's an interdisciplinary task force drawing top minds from physics, mathematics, astrobiology, information theory, quantum computing, cosmology, and even linguistics and philosophy, operating across multiple institutions under strict non-disclosure agreements. Their primary task: analyze the Voyager data exhaustively and try to understand the anomaly. Crucially, they've begun actively reprogramming Voyager 2. Launched shortly before Voyager 1, Voyager 2 took a different path through the outer solar system and is also now in interstellar space, but heading in a different direction and through a different region of the interstellar medium. It serves as a vital control experiment. Commands are being sent, a slow process, given the light travel time, instructing Voyager 2 to perform specific sensor scans and data collection routines designed to look for similar anomalous structures. If Voyager 2, on its independent trajectory, detects the same or a similar phenomenon, it would massively strengthen the case that this is real and not unique to Voyager 1 or its specific path. If it finds nothing, the mystery deepens. The quantum AI continues its tireless work, sifting through the trickle of new data still arriving from Voyager 1, searching for further patterns, changes, or clues that might unlock the nature of this cosmic enigma. Every single day, as Voyager 1 sails another million miles deeper into the unknown, we potentially learn a little more about what could be the greatest discovery ever made. This unfolding story, regardless of the ultimate explanation, carries profound lessons for us right here, right now, in our daily lives. One question everything. Voyager's discovery reminds us that our understanding is always incomplete. What we hold as fundamental truth today might be revised tomorrow. Be willing to question your own assumptions, biases, and the obvious truths in your life and work. True growth comes from intellectual humility. 2. Look again with new eyes. Decades-old data yielded revolutionary insights when viewed through a new lens, the quantum AI. How often do we dismiss old ideas, past experiences, or familiar situations? Sometimes, applying a fresh perspective, a new tool, or simply renewed attention can reveal hidden depths and opportunities we completely missed. 3. The power of the journey. Voyager's mission wasn't intended to find this. It was sent to look at planets. Its greatest potential discovery came long after its primary mission ended, simply because it kept going, kept observing, kept pushing the boundaries. Persistence, curiosity, and the willingness to explore beyond the initial goal can lead to unexpected and extraordinary rewards. Embrace the journey, not just the destination. 4. Embrace the unknown. The universe is vast, complex, and fundamentally mysterious. This discovery, whichever way it resolves, highlights how much we don't know. Instead of fearing the unknown, perhaps we can learn to embrace it as a source of wonder, motivation, and endless possibility for learning and growth. Facing ambiguity with courage and curiosity is a vital life skill. What do you think is happening out there, 15 billion miles away? Could mathematics truly be a universal language recognized across the cosmos? And if this is contact, what does it mean for humanity's future? Ponder these questions. Let them spark your own curiosity about the universe and your place within it. Thank you for joining me on this incredible journey to the edge of known reality. I sincerely wish you all good health, clarity of mind, and a continued sense of wonder about the magnificent universe we inhabit.